Welcome to this tutorial on LAMP Stack. This is a special tutorial being recorded in the context of COVID-19 as requested by the NPTEL under the Database Design Additional Lectures. As you know, COVID-19 is presenting a very challenging situation for all of us, and it can also be an opportunity. This is making us record this lecture from home, and also most of you are also learning online as this challenge unfolded. Before I go into the actual tutorial, hands-on tutorial, I would like to set the context for this tutorial. Let me present a few slides for you before we jump on to the hands-on tutorial. Now you can let me share my screen. And bring up my slides. So this is a database design LAMP tutorial. I am Dharani Pragada Janakiram, professor at the Department of Computer Science and Engineering, IIT Madras. So we have earlier recorded in 2003 the database design lectures. And now I want to do an additional LAMP stack tutorial as part of the course here. To set the context for LAMP, LAMP stack is the most popular stack for developing the database applications. What does this LAMP stack stands for? L stands for Linux, which is the operating system that we will be using for developing our applications. In this particular case, I will be using the BOSS MOOL Linux version. BOSS stands for Bharat Operating System Solutions from CDAC Chennai, and minimalistic object-oriented Linux, which is a unique distribution developed at IIT Madras, Distributed Object Systems Lab at IIT Madras. And this version of Linux kernel is unique in the sense that it supports object-oriented device drivers written in C++, as well as message filters written in C++ for working with the Linux kernel. Any system call to the kernel can be intercepted transparently by a C++ message filter, and this can be used for a variety of purposes, which can include optimizing the performance of the applications running on top of the operating system. I'll discuss this more as we go further, why I'm using this version of Linux kernel developed at Distributed Object Systems Lab at IIT Madras. Incidentally, IIT Madras has a patent as well as trademark for this technology, filter technology. And then the A stands for the Apache Web Server. This is again an open source web server that we will be using as part of developing our applications. Here the web browser is going to be the front end for our applications. And the back end, we are going to use the MySQL database, which is again an open source relational database system that's available for free download and installation on your systems. Then for connecting the web pages with the response from the web pages with the backend database system, we will be using the PHP, Perl, and Python. In this particular case, we will use Python, which I'll show you how you can connect the Python programs with the backend MySQL server. And the actual application that was developed, we're going to use the Perl as part of the development process in the application that is shown here. Okay, you can download all this software independently and then configure the stack yourself, but it is quite challenging often for students to get all of them and install these into the system that they're using. So a simple mechanism could be just use the VDI file, which is pre-configured with the BOSS MOOL operating system and the Apache web server and MySQL, and Perl and Python is also available for download. You can just download this VDI file, which has the entire LAMP stack built into it, what I'm going to use in my tutorial. This VDI file is also preloaded with the IIT Madras rate contract application developed using the LAMP stack. This whole application is put into the VDI. Now, IIT Madras purchases regularly computer components, and then for that they enter into rate contract with various vendors. Now, here is an application that supports this application by allowing the vendors to quote into the system through a reverse auctioning process, and the system automatically takes the lowest quotation and then approves it for the faculty and other project staff to buy computer systems and other spare parts and other accessories like toners and things like that. So this was developed in 2003, and then this is an in-house application, and then this was used for quite some time internally. And this is what is pre-configured into the VDI file for use. What we are going to do is to make you understand the full LAMP stack, how you will develop the LAMP stack. We will give you this application for studying, and then you can modify this application for the assignments that are given to you. But these assignments are not part of the tutorial here. You can write to us after listening to the tutorial, and then I can give you the assignments. And if you're successfully able to do the assignments, you're going to get a certificate, BOSS MOOL Database Design Certificate from IIT Madras. For downloading this VDI file, you can go to this website here. This is our lab website. This is the BOSS MOOL website. You can go to the downloads. The downloads will actually give you the VDI file here. You can download this VDI file and use the virtual box for booting up any of these VDI files. One of the reasons why we are actually using this MOOL operating system as part of this tutorial is you can do a lot of optimization at the operating system level using the MOOL. For example, the BOSS MOOL has been used for optimizing the Hadoop block placement in heterogeneous nodes. Hadoop normally places a 64 MB block or a multiple of 64 MB block on each node. But in the heterogeneous distributed system context, all nodes are not equal, and some will be having a good disk performance, some may not have the very good disk performance. So you can use the message filters of MOOL to collect the runtime statistics of the performance of these disks, and then accordingly decide what is the size of the block that you want to place on each of the nodes in the distributed system for optimal performance of, for example, MapReduce programs for big data analytics. There's a research paper towards this, which is called the Tula paper, and you can actually refer to that paper in our home site here, and it's available for free download as part of the website here. And that's also one of the reasons why I'm actually trying to show you how you can use the MOOL operating system for developing database applications as part of the LAMP stack. So you can go to this website and then can download the VDI file. Once you have this VDI file, you can get 2 assignments for the IATM rate contract application by sending email to me at djram@csc.iatm.ac.in, and also instructions on how to do the assignments after watching this LAMP tutorial. If you are able to do these 2 assignments and submit, you will get a BOSS MOOL database design certificate from IIT Madras. In fact, the first NPTEL video lecture on database design has also these details of IIT Madras rate contract application. In terms of the coverage, it's important to understand that real-world applications are not just to deal with just writing SQL statements, which often you do as part of your lab. Real-world applications are end-to-end requirements, and you need to have the full stack. For example, the operating system, the web server, the relational database system, and also the scripting language that connects the backend server to the backend database system. So you're going to use a complete stack like the LAMP stack for developing your applications. What you do in your lab exercises often is just do simple SQL commands, but that's not enough for you when you want to develop a full LAMP stack application. So database course is not to be seen in isolation. You need to understand the internals of the operating system, internals of how the database is running on top of the operating system, and how the web server is interacting with the database using the scripting language. So you need concepts from all of this to be able to develop a real-world application. Often again, in real-world application, you don't develop things from scratch. You're given applications that are already developed, and continuously the requirements will change, and you will be asked to modify the existing running applications for the new requirements that came up. So this is generally what happens as part of the software engineering in the industry. So one of the key things is to understand how an existing application is running, and then doing a modification to it. The 2 assignments were designed mainly from this point of view, that a running application is given to you. So you need to understand how the running application has been developed, and then two changes, requirements changes are given to you as part of the two assignments. You need to modify the the application for the two assignments. So what we will be doing in this tutorial is we'll show you how to develop the database applications using the LAMP stack. The focus is also not on the concepts. We'll connect the concepts, but then more on the system orientation of how the database system, internals of the database system, and how it will be running or working. So this will give you a deeper understanding of the concepts from the systems perspective. This makes you a true engineer, in my opinion, and that's also the objective of this tutorial. Now, one of the key things that we want to promote is this open source way of learning. Now, one of the things that you can see in the LAMP stack is the whole source code of Linux is available for you. This is what we did. We took that and then we have added, modified it, added the C++ component to it. The whole Linux kernel is written in C. So if you want to add a C++ device driver, or you want to use the C++ exception handling in the Linux kernel, it's not possible in the current distributions. Whereas here you can actually, in our MOOL version, you can add the C++ device drivers, and you can also, this also comes with a transparent message filter framework with which you can intercept any system call. In fact, this was used in the Android operating system also, which was built on top of the Linux kernel. The tutorial will assume that you have downloaded the VDI file and you have started using the VirtualBox application. So that's the starting point for this. Since the whole source code is available, we are going to show you as much as possible the internals of the working of the database system and how you can performance tune your applications when you understand the internals of both the operating system and the database, and also the web server. Now, given this brief introduction, now let us jump into the hands-on tutorial, and I hope you will swim comfortably with me along with this tutorial, and let us have fun learning the LAMP stack and how database applications are developed using the LAMP stack. Let me now get into the actual VirtualBox. The VirtualBox is Oracle VirtualBox application you can download from the Oracle VM VirtualBox Manager. And once you do that and you got the VDI file, you can have that running as part of the Oracle VM. And that's what I've done already here. So we have the BOSS MOOL MySQL, which includes all the components of the stack, which I've listed earlier available. So let us get on to the running system here and then see how the applications are developed here. So this is the BOSS MOOL, which we are referring to. This is the basic Linux operating system, extended Linux operating system with the MOOL kernel, minimalistic object-oriented Linux kernel. That's what I'm actually using in this VDI. Now, the password for this is just BOSS MOOL. So if you're using this, you will get to the same thing. Now, as you can see, this is a running application that I'm actually trying to use. So for just giving you an understanding of this, this is the shell that I'm using. This is the root shell that I'm using. Again, the password for this is same BOSS MOOL. So if you for the root password, if you want to get into the root password, it's the same. Now, this is the operating system BOSS MOOL. Now, the MySQL is pre-configured into this, which means that you can run your operator database program on top of the operating system. So in this particular case, you can start the MySQL program by giving the user and the password. So the user is root, and the password also for this is root. That's how it's pre-configured. So you can start this MySQL program, which is a relational database program that is running on top of the operating system. Now, this is important for you to understand the difference between files and the program that you are running now as part of the MySQL. This is a relational database system. If you want to create an operating system file, the file is just simply, you can create a file by saying that, you know, some, you can create a sample file by saying that use any editor of the operating system, and then create, this is a tutorial so this is so if you get to see this, so this is the I'm just reduce the size of this. This is the tutorial session for Swayam. Swayam is a very nice name because it represents that at the end of it, you should become your own teacher. It's not possible for people to teach you all the time, right? So you should become a teacher yourself. You should internalize the teacher. So the Swayam is a very good name that the government has given for this distance learning. The other name they also have is this Ekalavya, I guess, which is again a symbolic representation of how you can learn by keeping the picture of the teacher and having the concentration for learning. So if you just use the sample.txt, this is an operating system file, right? You've created. Yet there is no format for this. You just can put anything here, including whatever text you want or whatever you want to add here. There is no format for this. On the other hand, if you're using a spreadsheet, you have those cells and you put data into those cells, and you can add up, do lots of things which are pre-configured within an Excel system, right? Now, in a similar way, but if two people are simultaneously opening this sample.txt and writing, the operating system no longer guarantees how things will be in that file. They could be garbled up. So there's no concurrency control. Okay, if two people simultaneously operate on this, there is no specific model as part of the, just simply a white page in which anything can be written. But on the other hand, if you look at the relational database system, there is specific model, relational model for the data that you enter into the system. And on top of it, it supports the SQL as part of data manipulation and data access to the tables that you have created as part of your system. So we are now creating a relational database system on top of the operating system, which means that the relational database system also uses the operating system files, but then builds a model on top of them, which we're going to see when we go deeper into it. To just understand the relational database system, let us now look at this MySQL program, and let us see the user is root here, and the password is also root. So let us start this MySQL program. This is a relational database system. Now I'm running a program on top of the operating system. Whereas earlier I used the VI editor for just working with the files. Now I use the MySQL program for working with the relational model and supporting the SQL on top of the relational model. So this is what it got started now. So you have the MySQL prompt here, as opposed to the operating system shell here. Now I have the MySQL shell here, which means that all the commands that I enter now here have to be understood by the MySQL shell. Here the VI is an editor program understood by the shell. If I do ls, it will list all the files in the directory. So these are all the shell commands, and then the operating system shell understands those commands. Once I have started running MySQL program and I'm inside the MySQL shell, I will be able to give commands that this MySQL will understand. For example, I can ask, show me all the databases that are there in this. So these are all the databases that are there as part of the, can see that, right? Performance schema, and then rate contract, test, all these are available as part of the right. So you can say use a particular database. For example, this is a special database, information schema. Okay. So you should be able to, this database is changed to now information schema. Here you can say, show me all the tables. Show tables under this. So you can see these are all the tables that are there as part of this, right? So you have, for example, user privileges, DB transactions, all this, right? So you can see the tables by just asking show tables. These are all the commands that the MySQL understands. You can say describe, for example, engines. What are the different engines that are there? So this shows the schema of this particular table. It shows the field, engine is varchar, and null. No, it's a no. It cannot be null. Then the key, it's not a key. Then is there a default value and anything extra? So basically, you have the each of the attributes in the table and the type, and then the other attributes as part of how this attribute is defined in the table. Right? So you can see that by using the describe the table. This gives the schema of the particular table. You want to see what is all the data that is available in this table. You can just go and then say select from engines. So these are all the engines available. For example, for example, my ISAM, InnoDB, black hole, memory. Okay, so these are all the different engines, storage engines that are available, which we're going to see a little later, how these storage engines will work and how we can use an appropriate storage engine depending on what our application is doing. So this takes us into the internals. For example, this information schema is common to all the databases that we will be developing, and then this is internal. So all the information is available as part of the information schema database, right? So, for example, now let us try to create a database and then see how we can work with a database. For example, let us see, we want to create a database, okay? And in this particular case, we'll say Jankiram IITM. So basically, we will try to create a database with my name at IIT Madras. So it's already exists. So we will just say create database, okay, IITM Jankiram. So hopefully this is not available. So this is all right. So we could create this database. Now we can say use IITM Jankiram database. So we will be using this database. So the database has been changed. This is equivalent to actually creating, which will show a directory in the operating system in a specified location, a directory called IATM Janakiram. When you say use, this is equivalent to actually going into CD into that particular directory. Okay. Now you can create a table, create, let us say we want to create a table called persons in this particular case, and then we will give the person an ID, okay, as an attribute. So this is an integer, and then we will say not null, uh, and then we will say name as additional attribute, which is a varchar, let us say, is of 20, and then let us say PAN number of this person, okay, again will be an int, okay, and then we can say we want to create primary key as the ID. So ID is the primary key for this. The reason why you want to do this is basically if you have understood the concepts of how the normalization has to be done in each of these relationships. If the attribute ID functionally determines both the name and the PAN number, then this is in a certain normal form. And then the various normal forms will help you to make sure that in the table there are no redundancies are across the tables. For example, the simple fact of normalization is you need to store one fact at one location. You don't want to store the same fact in multiple places. So that's where basically you will use either functional dependencies or multi-value dependencies to understand the relation between the attributes in a relation, and then use that for normalization so that one fact is stored only in one place. That's a key thing of normalization. So in this particular case, if you're saying primary key is ID, you're in effect saying that this table will never store duplicates of the same ID and then store different information for the name and the PAN number. One ID will have only one unique name and then unique PAN number. The same ID, if you have, so you will store this ID only once. So if you try inserting a duplicate with the same ID, it will not be allowed by the MySQL system. It will complain saying that you are inserting a duplicate. So this is how you create relations and the corresponding tables in your database. So that becomes part of your database design course, which you have studied as part of the concepts. In this tutorial, we will not go there, but then we go more at the systems orientation of the whole thing. So the concepts you have already learned as part of your regular lectures. Here we are only looking at the system orientation for this. For example, these persons will become now a corresponding files under the directory IATM Janakiram in the operating system. So that's how this MySQL will manage all these which we are doing here. Okay, so it's running on top of the operating system. That's what you should understand for the first point. So you're not dealing with any more files, but these files will be created by the MySQL system, and it will use them for doing whatever you need to do. For example, using this, you can only create tables by giving the schema. So you can also insert only based on what schema you have created. So you're creating a higher level abstraction on top of the files using the relational database system called the MySQL. Okay, so this is how you will create the create a table. So now we have created a table here. Now we can insert into this table, for example, insert into persons, ID, name, and then PAN number. So let us insert some values into this. I'm just using a few values here since it's a demo thing. You can import a much larger set of values into this in other means as well. For example, we can say Ram and we can say his PAN number is 101. I'm just using some, so then you can say these are all dummy values, not Sham. So we will say 102. This is for just to make you understand the concepts, how this system is working, and then how we can insert values into this. Then we can say Gopi, and then this becomes 103. I'm just using a sequential thing, and then we can do 4, which is Neil, and we can give 104. Okay, so we can insert into this person's. Now this is the table, and we want to insert the following 4 records into this particular thing. So we have inserted now, query OK. So 4 have been inserted. So you can just check whether you have inserted all of this correctly by looking at, right? So we have got all of this. ID is 1, RAM, and then PAN number. So we have inserted 4 records into this database now. Okay. Now let us also create another one. Let us say we also want to give an Aadhaar number for the person. Okay. So we will say now create table Aadhaar. Okay. Now we can say I want to create again the same ID. So basically we'll say int, and then we say name, which is varchar 20. Okay. Now we will give the Aadhaar number here, okay, which is int, right? And again we'll say primary key is ID even in this table. Okay, right? So we can now create another table, Aadhaar table. Persons table is what we created. Now we can create Aadhaar table. Now again insert into this Aadhaar, okay, ID, name, Aadhaar number, and we can put the values here as we put the previous thing. So 1 RAM, same thing, but then here it's actually Aadhaar number. So I'll just use 501. There I've used, so just using a different index, starting index for this 2. Then I have Sham, right? So and then I have 502 here, and then 3 Gopi, and then we will say 503. To just show you how different joins will work, I will put a new record here. We'll say Kamal here. So we'll skip 4 there, and then we'll put 505 as part of this. Okay. So we'll accept all the first 3 records. Now we have inserted a new record called Kamal here with 505. Okay. So now again you can check this Aadhaar. Okay. Select star from Aadhaar to see if everything got done properly. Okay. So you can see these are the things that got inserted, right? Now, for a particular person, you want to get both PAN number and the Aadhaar number. Okay. You want a table. So you will create now a higher level abstraction by saying that these 2 are different tables now. You can join these tables and create a higher level view, which includes both the PAN number and the Aadhaar number of the person, right? Because these were created independently, because some people have given their Aadhaar numbers and some people have given their PAN numbers. So you have actually got 2 tables, and then you have created both these 2 tables. Let us see how we can join both these 2 tables by saying that I want to have person's ID, person's no, name, person's PAN number, and I want to have the Aadhaar number, okay, of the person from persons. Now you want to do a natural join, which means that if both things match, the IDs match, you want to join both these tables. So you do the inner join, okay. You say I want to do the inner join of both these tables on the condition that person's ID is equals to the Aadhaar ID. So if this matches, then on this condition, yeah. So we're just making some syntax while typing this thing. So you can see here we are doing the inner join. So select person's ID, person's name, person's PAN number, and Aadhaar number from persons, and inner join Aadhaar on person's ID with Aadhaar ID. So when we do this, you can see here, whenever the ID matches, only with respect to Neil and Kamal, we don't have this matching. So it gets both the ID 1 and the name Ram, then his PAN number is 101 and Aadhaar number is 501. Okay, right? So this is an inner join, joining both these tables together. We can also do a left join, which means that you want to only have everything from the left table, that is person's table. We want to join with Aadhaar, okay, when these two are same, okay, right? So whatever is now additional thing that will be available in the left table will be brought, and then you can see how the left join works with this. Now you can see here the Aadhaar number is null for Neil because it doesn't join, but then it is this record is available in the persons table, so this will get added in the left join. Okay, you can also do the right join, which means that you want to take the right records available in the right table and then join with the left one, which means if you do the right join here, you're going to get the but then person's ID and then the person's this thing will be not there, so we can additionally change this to Aadhaar now ID, because this is we are actually adding the available information from the Aadhaar name. So PAN number suddenly is going to be null in this particular case. So we can do a right join. So which means from the right table now we are going to do the additional. So you can see Kamal is there in the right table, in the Aadhaar table. So that gets added now, okay, because we are doing the right join. And you can see PAN number doesn't exist for the Kamal, so it becomes null, okay. Now if you want to say, I want to do the right join and then want to get all those people who doesn't have the PAN. You just want to say where the PAN number is null, okay. So this is saying that I want to get all those people who have an Aadhaar card but not PAN card. So that's what you want to now do by joining both these tables, okay. Yeah, yeah, is where PAN number uh, is So sometimes what happens is there's no space, so it's not visible here. So you make those kind of silly mistakes sometimes. Okay, so you can see the idea is no, that's a kind of mistakes in this kind of no, small window that I'm using for presenting. You won't see the gap there, so that will cause the syntax problems. Otherwise, there is no problem with the syntax that we're doing. Okay, so the ID is 5 now here. So Kamal is the one who has the Aadhaar number but not PAN number. Okay, same thing you can do with left join. For example, you can do the left join, and then you can say where PAN number is there, but then Aadhaar number is not there. So you can say Aadhaar number is null. Okay, so you can do that. So now here is the Neil who has a PAN number but not Aadhaar number. So you can do the left join and the right join, inner join, and you can also do the cross join. For example, you can do here cross join where all the first ones will be joined with the second table. So you can say cross join. You want to do the cross join, so you don't want to now use the null and all that stuff. So you basically want to do the cross join here. Okay, the cross join has produced um, where the person ID is equals to the Aadhaar ID. That's what it has done. So what you should do is, in a that's a condition that you have applied, join and Aadhaar cross join. So if you just do the cross join, general cross join, you can see that the first record will be paired up with the second record. All possible pairings are actually obtained here. So 101 will be paired up 501 with all the other records. 502 will be paired up with all the other records, 503, and the second one has 505, which again gets paired up with all the other records. So this becomes a cross join. So what we've done here is the cross join as part of the whole thing here. Okay, so it's possible to do all the no, different kinds of joins using this particular thing. Let us understand a little deeper on how this translates to the lower level operating system thing and come back here again. Okay, so for this, what we're going to do is we will just go back to the operating system shell. Now you can see the whole operating whatever we did here will be under the varlib mysql. So this directory starting when you install it, you can specify under which directory this installation will happen. Now in this, if you go here, you can see all the databases that got created have a directory here. All the show databases there has the corresponding directories here, which are available here. For example, in this particular case, you can see the CD, okay, IITM Janikiram is what we had just now, this is the database that we had created. So all the things that we had created, for example, you can see the Aadhaar from, persons from, all of this have got created. These are these are the schema that got created as part of the whole thing here. Okay, now you can read the corresponding for example, if you go to the nptel directory, for example, this is the other one which we had created, and you can see here everything got created has, for example, a schema frm, and you also have got the data and also the index files. These are available as part of each of this here. If you want to read the for example, the schema from this file, so you can specify that by saying varlib mysql, right, nptel, and then you can say you want to read the this, and you can use this tool. So you can see here, this is the schema of this table, nptel.cloud, roll number, name, okay, and category. So these are the three things, and you have actually put the roll number as a primary key here. And this is the storage engine that we have used for this, which is basically the my ISAM, okay, right? So you can specify different storage engines, and for this can be, for example, my ISAM will not support the transaction properties, which we will see a little later. If you use a InnoDB, it supports the full transaction properties on the table, so you can get logs, and then so it's possible to get the record level logs using the InnoDB. Whereas if you're using the my ISAM, you will not be able to get all of this. So basically, underneath, the whole thing becomes a set of files, the operating system files, which are managed by the MySQL program. Okay, for example, we can look at the index by using this utility MySQL check index, right? And you can you can actually say, you have to also say here what is the server where this whole thing is running, right? So you have to give the password of this, and then you say this is localhost, running in localhost. The default port where this is running is 3306, right? And then you want to do the index check, and you want to have the complete verbose here, and you want to do the nptel persons. Let us say this is where you want to do the check on this, right? um, you want to get the full verbose there, then you can do that. You can actually do the help to see which are all the things that are available here. So you can see based on this, for example, the index that you have on this is the B tree, okay, right? So you can by giving the stats, you can see how these indices are actually performing. For example, in this particular case, you can see the database is nptel, the table is persons, name is primary, so the type is basically B tree, okay. The index tree that is created is B tree, and this is what will be used for querying as part of the as part of the whole thing there, right? So recording from home has no the additional challenges. Um, you probably have to bear with us on some of these, yeah, crude things that we are doing here to just get the whole thing going. Okay, so B3. So you have an index here. So this will be used while joining. For example, when you go back to the case where you have the persons and the Aadhaar number, let us say you have 1,000,000 records in Aadhaar, and then you only have about a lakh PAN numbers. And let us say you're indexing, and then based on the ID in both these tables. So when you pick the first ID and then index into the second table, you don't need to search through the whole table if the index is available for the second table on the ID, right? Then the matching is going to be faster. Only 1 lakh records of the first table have to be indexed into the second table, and then that's how the join can happen. But on the other hand, if you're actually using Aadhaar and then joining it with persons, and if there are 1,000,000 records in Aadhaar, and all the 1,000,000 have to be indexed and then searched into the second table, so it's much simpler for you to, it's much faster for you to do the joining from from persons to other based on the number of records that you have internally there. Okay. In fact, you can get a lot of statistics of this. Okay. By just adding the stats index here, you should be able to get the uh, if you actually use this, then you probably will get the statistics of the if you want to see, for example, how the indices are performing, you can get it by doing the statistics as well. Probably it is double quote here. So you can see here, not enough data to calculate best and worst in indices. So if they're available, then it will suggest based on how the accesses have happened, you can get the best and the worst in the indices for this particular table based on what was. So based on this, you can change the indices, which are the best indices for this particular table based on the previous history and performance. And with MOOL, what you can do is, if this information is available, you can automatically drop an index and add a new index based on the best and the worst indices, so that the operating system is able to fine tune itself based on the indices that are available and the performance statistics that are available on the table. So all of this will be possible by going underneath and seeing what's happening with the operating system side of things. For example, this is just a file access at the end of the day. So if the file is kept in memory versus the file is kept on the disk, and then how often it is being fetched, and then what is the read-write latencies that are happening on a particular node, all of this information can be used to fine-tune the performance of your operating system. We're going to stop here as a first part, and then get on to the transactions part, and then looking at how the storage engine affects the transaction properties in the next part, and subsequently go on to the final part of showing how the database application works by connecting from the Parallel PHP or Python to the backend MySQL database.